So today we're going to learn about how to graph a logarithmic function or a logarithmic equation. Okay. So a couple of quick things with logs to kind of remember. If you have log base b of x equals y, okay. Again, the answer to a log is an exponent, so y is the exponent that I put on my base to get x. Okay, so what does that mean? That means b to the y equals x. Okay, so these two equations are actually equivalent to each other. This first one is a function of y, the second one is a function of x. Okay, so these are just two things that mean the same thing. They're just a different way to write it. One is a logarithm and one is an exponential. So we're going to use this idea when we graph. So for starters, we're going to graph kind of a really basic one. Start with kind of a parent function. Y equals log base 2 of x. Okay? Now, one of the difficulties with logs is it is kind of a challenge to figure out x values, to try to find what numbers can I take the log of. Okay? So remember, the idea is y is the exponent, so you're really kind of figuring out 2 to some number, x, 2 to two different powers, like 2 to the second is 4, so I can take the log of 4. 2 to the third is 8, so I can take the log of 8. Okay, so it's a little bit of a challenge to try to figure out what the x value is. So the way we do this is we actually rewrite this. So I'm going to write this as 2 to the y equals x. And I'm going to make a table from there. What's a little bit unique about this is the table I'm going to make, instead of picking x values, plugging them in and finding y's, I'm actually just going to pick y values. Okay, so I'm just going to pick some kind of typical ones that we normally would have picked for x, but this time we're picking them for y. So I'm going to pick -2, -1, 0, 1, and 2. So then I'm going to use this equation over here to find my x value. So 2 to the -2nd. Well, remember, negative exponent reciprocates, so 2 to the 2nd is a 4th, so 2 to the -2nd is 1/4. Or 2 to the 2nd is 4, so 2 to the -2nd is 1/4. 2 to the -1st, that's a half. 2 to the 0, anything to the 0 is 1. 2 to the 1st is itself. 2 to the 2nd is 4. So now I have my points. 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. And I'm going to plot those. So 1/4, I'm down at -2, somewhere around there. 1/2 is -1, 1, 0, 2, 1, 4, 2. If I kept going, 8 would be 3. So 1, 2, 3, 4, 5, 6, 7, 8. We'll be up at 3. So what I get for a graph is I get something that looks like this. Alright, so really quick, just fix this graph a little bit, make sure it doesn't look like it comes back down. The graph's going to keep increasing. Okay. So some of our key features, really quickly, domain. Okay. All logs have a vertical asymptote. So this graph has a vertical asymptote right on the y-axis, so at x equals 0. So the domain is x values that are greater than 0. You can only take a log of a positive number. Okay, so x values can only be positive, or at least what you're taking the log of. Range, you got one arrow that points down. This one's going to, over here, is going to keep going up on this end. So even though it kind of looks like it flattens out, it's still increasing. So your range is going to be all reals. X-intercept, that's where the graph crosses the x-axis. That's at the point 1, 0. We saw that from our table. Y-intercept, in this case, there's no y-intercept. Graph, again, has a domain of x is greater than 0, so it's never going to cross the y-axis unless there's a horizontal shift. Asymptote, one of our important pieces. That's x equals 0. So that's sort of that standard one is going to be x equals 0. It's that vertical line that I have dashed in red there. And then our end behavior. End behavior is going to be just a little bit different for this one. So our end behavior, the left end doesn't go to negative infinity. The x actually gets close to 0, close to that asymptote. So as x approaches 0, the y goes down to negative infinity. On the right end is a little bit more traditional, the right arrow. As x goes to infinity, y goes to infinity. Okay, so one of the interesting pieces with this one is that end behavior, the left side one is going to have something to do with the asymptote. So there are two arrows, arrow on both ends, but one doesn't go left forever. It approaches that vertical asymptote. All right, so there's our graphs. General shape's going to kind of look like this, and we're going to do kind of one more example for us. All right, so what if we want to graph y equals log base x minus 1 plus 2. All right, so what I want to do here is I want to just look at the parent function. So I just want to look at y equals log base 2 of x. You can ignore the minus 1 and plus 2 for just a moment. So this is going to be really important to really use, I think, transformations is going to be your best bet. So what we're going to do is the same thing we did just a minute ago. I'm going to rewrite it as 2 to the y equals x. Make my table. So remember we picked y, so negative 2, negative 1, 0, 1, and 2. 2 to the negative second is a fourth. Negative first is a half. 2 to the 0, anything with a 0 is 1. 2 to the first is 2, and 2 to the second is 4. So same points. Okay. Then we're going to apply our transformations. So let's kind of get rid of this for a second. All right, what are our transformations? Well, first we've got this x minus 1. Remember, anything attached to the x moves left or right, and minus 1 will move it to the right one. Okay, so really what we have is we have a right 1. Okay, what that's going to do is going to add 1 to all the x's. So 1/4 plus 1 is 1 1/4, or 1 1/4. 1/2 plus 1 is 1 1/2. I'm moving every point to the right one. 1 plus 1 is 2. 2 plus 1 is 3, and 4 plus 1 is 5. So those are my new x values. Similarly, I have this plus 2. That's going to move the graph 2 up. So negative 2 plus 2 is 0, 2, 3, oops, I messed that one up. Negative 1 plus 2 is 1, 0 plus 2 is 2, 1 would be 3, and 2 would be 4. Alright, so those are my new points. So really what I'm going to plot is I'm going to plot 1 1/4, 0, 1 1/2, 1, 2, 2, 3, 3, and 5, 4. Okay, the big piece is what you should be noticing is that the x's aren't getting closer to 0, they're now getting closer to 1. So that horizontal shift right here is going to dictate where that vertical asymptote is. Okay, so I'm going to come back over here and sketch my graph. So first thing I'm going to do is I'm going to dash in that vertical asymptote. Okay, at x equals 1. And let's plot some points. So 1 1/4, 0. So 1 1/4 over 1 1/4, I'm going to be at 0, somewhere around there. 1 1/2, 1. So 1 1/2, let me up at 1. 2, 2. So over 2. Make sure you're always counting from the origin. Don't get stuck counting from the new asymptote. Happens sometimes. So 1, 2, up 1, 2. Whoops, accidentally. There we go. 3, 3, and then 5, 4. So 1, 2, 3, 1, 2, 3, and then that'd be 4, 5, 1, 2, 3, 4. Alright, let's attempt to kind of get that graph in there. And there it is. So there's your graph of your log. It's been shifted right and up. Okay, so again, idea is just get that parent function, ignore the transformations, rewrite it as an exponential, sketch your graph. Alright, domain, this time x is going to be greater than 1, because I've shifted it to the right one. Range is still all reals. X-intercept, let's come back here. That would be when y is 0, so that's 1 1/4, 0. So x-intercept is 1 1/4, comma 0. Y-intercept doesn't cross the y-axis. Now I can get a y-intercept if I move the graph to the left. So if we got some transformations that move the graph to the left, we will get a y-intercept. Asymptote, we identified that right away. That's that horizontal shift, the right one. And then our end behavior, again, as x approaches the asymptote, so as x approaches 1, the arrow is pointing down, so the y goes to negative infinity. I can get a positive infinity. I can have this graph flip if I have a multiplier of a negative in front of the log. So just kind of some transformation ideas. And as x goes to infinity, y goes to infinity. As I go to the right, the graph increases very, very slowly. Okay. So quick recap. When you have a log function, ignore all the transformations. So just focus in on the y, the log, the base, and the x. Rewrite it as the base to the y equals x. Make your table. Pick y's. Plug them in for x. Pick y's, plug them in for y. Take your base up to that power to get your x's. Then come back and look at your transformations. You can have the horizontal shifts identified here. You have the vertical shifts. And again, I could have some multiplier or something out here in front. I'd have to multiply the y's by that number as well. You should be pretty familiar with all of those pieces. Come over, sketch the graph. You can see kind of what that general shape looks like. So again, we have some shape kind of looks like this. It's going to have a vertical asymptote at that horizontal shift, and then find all your other key features.